In other videos, I cover the difference between independent and dependent samples, also known as matched pairs, and also how to test the mean, or the means rather, from dependent samples. In this video, we're going to look at independent samples. So in other words, this video is about hypothesis testing and confidence intervals for two means from independent samples. Now, this is another notation heavy section, and so it's always wise when you dig into a particular section in this part of the course to make sure you're totally clear on what each of the notation items refers to. So in this video, we're going to use n sub 1 and n sub 2 for the sample sizes respectively, and they don't have to be the same, and that is a dead giveaway when you're looking at whether it's matched pairs or whether it's independent samples, because if the samples are not the same size, then obviously you can't have matched pairs. The converse is false. We're going to use x sub 1 bar and x sub 2 bar for the sample means, and we're going to use notation for the sample standard deviations. In the text, it would typically be s sub 1 and s sub 2. On the calculator, it's s sub x sub 1 and s sub x sub 2, and so on. And then for the true means, the true population means, we're going to use mu sub 1 and mu sub 2. And so let's take a look at the framework within which we're going to be operating here. There are going to be three tests: two-tailed, left-tailed, and right-tailed. And when you have two samples, you got to remember that there's always more than one way to do each of these tests. Now you'll notice that the null hypothesis is a claim of equality, and the null hypothesis doesn't change from one test to the other. It's the alternative hypothesis that tells you effectively what test it is that you're doing. And since the order of the samples is arbitrary, each of these tests can be run, especially the directional tests, can be run more than one way. So that's something to pay very careful attention to in this section, because sometimes they tell you, sometimes they don't. And so you really have to keep your brain turned on. You can't go on autopilot in order to prosper in this particular section. Just a few more key points before we dig into our example. Sometimes you'll see this test referred to as Welch's t-test, and so that's a good thing to keep in mind. We are depending on the central limit theorem for this particular test, and so we have a couple of caveats that apply for that as well. Normally we would have to check those if they don't tell us that they have been satisfied. So we want our samples to be from known normally distributed populations if we have a small sample, meaning below 30. And if the sample size is 30 or more, then we're good to go. We don't have to worry about verifying that the population itself is normally distributed, although if it is, that's perfectly fine. We're not assuming that we know the population standard deviations, and there's another kind of a sub section that crops up here regarding pooled samples, and we don't do pooling. So in other words, we're only taking a look at the situation where we don't know anything about the standard deviation of the population. You're going to see a reference to degrees of freedom in this section here, and what we do is we take the sample size -1 from both samples and we compare those, and the smaller of the two values is the degrees of freedom. And so if you're using the calculator, obviously that's greatly automated, and so you can relax a little bit with regard to that, but it does come up from time to time. And you can also use a confidence interval here, and so we're going to showcase both approaches in this video here. For this video, we're going to use as our example the problem you can see on the screen in front of you right now, number 10, which is titled Walking in the Airport Part 2. And the problem asks, do business travelers walk at a different pace than leisure travelers? Researcher Seth B. Young measured the walking speed of business and leisure travelers in San Francisco International Airport and Cleveland Hopkins International Airport. His findings are summarized in the table. So we have a table there, and we're probably going to want to jot some of that down. Part A of the question is asking, is this an observational study or a designed experiment? You'd have to go back to the very first chapter to dig that up. In effect, what it's asking is whether there's an intervention or not. So when you have a designed experiment, you have some kind of an intervention. In other words, you separate the subjects into groups, at least two. So you may have like a control group and a treatment group, and typically that is what we would describe as the intervention. So there's no intervention here. That should be clear. We don't have people in a laboratory. We have people in an airport, and we're just watching them. So this is an observational study, and the reason is because there is no intervention. So I'll put that down in a bit, but let's keep on moving here. So they're asking in Part B here, what must be true regarding the populations to use Welch's t-test to compare the means? Well, we just talked about that. So we're saying, look, we have small samples here. You'll notice that both samples happen to be the same size, and that's great. But because they are both less than 30, we need to make sure that the sample data comes from a normal enough population. So in other words, we would be assuming that people's walking speeds are normally distributed. And we're not assuming that we know the standard deviation from either of the samples, because as we said, it's not necessary. So again, I'll put that down in a bit, but we're looking now at Part C, and it says, assuming that the requirements listed in Part B are satisfied, determine whether the business travelers walk at a different speed from the leisure travelers at the alpha is 0.05 level of significance. So that's really the crux of it there, and we want to think about what is it really asking. Let's put a few things down here. So here's what I've got down regarding Part A. Again, it's an observational study because there's no intervention. For Part B, the parent distributions, that is the walking speed of the business travelers and the walking speed of leisure travelers, needs to be normal. And then for Part C, I've summarized the table that they have given me there. And if you look at the calculator, actually the way that the information is given in the table is actually user-friendly. It's not always the case. Sometimes they'll mix up the order of things just to kind of goof on you a little bit. But in this particular case, as you go through, you see that everything is exactly where it's supposed to be. So let me show you on the calculator why I have it recorded in this way here. On the calculator, if you go to the Stat menu and you go to the Test submenu, the particular test that we want for this type of problem is number 4, the 2-sample t-test. And so, believe it or not, people do get confused about what test they should be using, and so that would definitely be something we would want to have written down. And so I'll jot it down in a second, but let's take a look at that test. You can see it has two different modes. It has a data-driven mode and it has a summary statistics mode. Now for this particular problem, we have summary statistics, and so in order to use this, we would have to switch. And when you press enter, you'll see how the screen changes. And so the order of the items that we would be inputting here is exactly the order that you see in the table. So you have x sub 1 bar and s sub x sub 1, n sub 1, and so on. And so it's exactly like we would have in the table there. So let's take a look at what we have down here. Again, I've jotted down all of my summary statistics, and the test that we're going to be using is a 2-sample t-test. And so if you were feeling like an exam question or something, just the fact that you write that down shows that you're aware, okay, that these are independent samples, and we're using this 2-sample t-test because they're independent samples. Let's see what else we can do here. So notice in Part C it asks, determine whether business travelers walk at a different speed from leisure travelers. So which of the 3 tests does that correlate to? Well, that would be a two-tailed test. Anytime they ask whether something has changed or whether something is different, usually that is code for a two-tailed test. And so that's what we're going to put down for our alternative hypothesis. And I think at this point we're probably ready to run the test and to write down the results of it. So we always want to have some record of what you are testing. And so as you can see, I've put down my null hypothesis and my alternative hypothesis. And if you wanted to indicate that you're aware that that's a two-tailed test, that's great. But at this point, we're ready to go to the calculator and put everything in. You can see my inputs here. And so I've keyed in everything from the table. And really the only thing I need to key in is the alternative hypothesis. And so you can see flashing down below where it says mu sub 1 colon, and then you get to choose. So as we said, this is a two-tailed test, and so the one that's flashing is the one we want. Now, as we mentioned earlier in the video, we don't do pooling. And so for this question here, it would ask whether we're doing pooling, no or yes. For us, the answer is always no. And then at that point, we are ready to calculate. And so let's run the test and see what we get. So we probably would want to jot some of those things down there. You don't need to write everything, but you know, obviously some of it we've already written, but we would definitely want to have the test statistic. We want to know what the p-value was, and the degrees of freedom, you know, is really not of any great interest for us, at least not right now. So we're not going to bother jotting that down. But let's put the other things down. So I've written down my test statistic, which we definitely want, because that shows whether you keyed everything in correctly or not. And we want the p-value as well, although, as always, if you choose to run the test using the classic rejection region method, I'm not opposed to that. It's just that it is rather time-consuming. You have to go to the table, you have to get your critical values, and so on and so forth. And of course, we'd want that written down because we want to know, you know, that you're able to do the test at least one of the ways. But anyway, we have our critical numbers from this here. Those two, not critical values, but critical numbers. And we're ready to come to a conclusion. Let's go back and look at the problem real briefly. So in the problem, in part C there, we were told to test this at the level of significance of alpha is 0.05. And so since our p-value was larger than that, we will not be able to reject the null. So let's put down our conclusion here, and then we'll look at how to do this using a confidence interval. So like I said, p-value is greater than alpha, and so we can't reject the null. And on a practical level, what does that mean? Well, it means that the evidence we have does not support the claim that business and leisure travelers walk at different speeds. Remember, we never accept the null hypothesis, but we can fail to reject it. Anyway, let's run this as a confidence interval and see. Now notice, alpha is 0.05, so if you wanted to test this using a confidence interval, you'd be using a 95% confidence interval, 1 minus 0.05. Let's run that. So I'm back here at the calculator, and I want to quit this. And so I'm going to go to the stat menu and the test submenu. And if you scroll up, you'll notice number 0 right there is the 2-sample t interval. That is the correct interval to use here. And so you can just select it by pressing 0. And you can see that everything is pretty much preloaded. All we have to do is go down and make sure that everything is what we want. And again, pooling is always no. We never answer yes in this course. It's not something we cover. And so we are ready to calculate. And there's our interval. It sure takes its time. So the key thing to notice here is that the left endpoint of the interval, which is negative 17.84, is negative. And the right endpoint is positive, 39.844. And so that means that the interval contains 0. And when the interval contains 0, that means we are 95% confident that the value represented by the null hypothesis is plausible. So again, if you go back and look at the test, the null hypothesis can be stated as mu sub 1 minus mu sub 2 equals 0. And so since the confidence interval contained 0, again, that means that we are 95% confident that that is a plausible value. And so we cannot reject the null. That's as we said. So I hope that's helpful. I have another example for you in another video. If you have any questions about this one, please feel free, drop me a line.